equal to half sigma x sigma y power by sin theta. What is the problem? These two are wrong, na? Other than that, okay. So let us start discussing from where we have stopped, right? So in the previous class, what we have found that in an inclined plane of an element, be it a rectangular or square element, if the forces acts on that element normal to the plane, that is in the x direction and y direction, or in the x plane or y plane, and normal forces acting as well as shear stresses acting on those planes, then if we take an inclined plane, okay, if we take an inclined plane which is basically makes an angle phi with the x plane in the anti-clockwise direction, and in that case we have seen that in that inclined plane there is the existence of normal stress to that inclined plane as well as shear stress to that inclined plane, and the normal stress and shear stress can be expressed in terms of what? In terms of the normal stress to the inclined plane and normal stress to the shear stress, along the inclined plane, shear stress along the inclined plane, it can be expressed in terms of what? It can be expressed in terms of sigma x, sigma y and tau x, right? And in terms of that angle, included angle phi, right? Now, the point here we will start our discussion today is where this phase will become maximum. Okay, so where this sigma n will become maximum. So inclined plane is at an angle phi. So what is the value of phi actually it should come where the sigma n will become maximum? What will be the value of the phi for which the shear stress will be maximum? So what does phi defines? Phi defines the location of the inclined plane, right? So if we want to find out the maximum or the minimum value of the normal stress sigma n, then what we have to do? We have to go to differential, right? So you know that for a maximum or minimum condition, what I have to do? So with respect to phi, I should differentiate this sigma n. So what will be the condition for maximum minimum? So the maximum sigma n or minimum sigma n with respect to phi will happen if we make d sigma n d phi physical distance. This is the condition of maximum minimum, correct? So if we do that, then what we will get? So considering this d sigma n d phi, you see, if I differentiate this with respect to phi, then half of sigma x plus sigma y will become what? This will become equal to 0. Correct? This will become equal to 0. Plus this half of sigma x minus sigma y cos 2 pi. What will be the differential? What is the differentiation with respect to phi? So it will be half of sigma x minus sigma y will remain constant. Differentiation is happening for the cos 2 pi, right? So minus 2 sin 2 pi. So this will become minus 2 sin 2 pi, and the remaining one term, that is this one minus, this will become what? Tau xy. So there will be 2 coming into picture, right? So 2 tau xy and then cos 2 pi. Sin 2 pi का differentiation is constant. Is it clear? Have you understood? So we are differentiating with respect to phi because we want to know that with what is the location of the plane and how the location of the plane is defined. The location of the inclined plane is defined with the value of phi, right? So we are differentiating d sigma n and d phi, d sigma and d phi, okay, and equating it to 0 for maxima minima. Now if we make this equal to 0, if we make this term equal to 0, then what do you get actually? So you see, you will get a term something like this. So if you can see this 2 cancels out. So you will get a simplified version like sigma x minus sigma y, and there is a minus sign coming out from here. This will be equal to sin 2 pi multiplied by sin 2 pi minus 2 tau xy cos 2 pi equal to 0. Clear? So now if you take the value of sin 2 pi and cos 2 pi in one side, then what will you get? You will get, so 2 tau xy cos 2 pi, this is equal to 0. So if I take this on the other side, then what this equation will become? This will become equal to this. So minus sigma x sigma y sin 2 pi equal to 2 tau xy cos 2 pi. Is it clear? Now if you now find out the value of sin 2 pi by cos 2 pi, which is nothing but tan 2 pi. So this tan 2 pi will be becoming equal to this minus sign will be going on the other side. 2 tau xy by sigma x minus sigma y. Have you understood? Is it clear? Is this clear? This equation derivation is clear? So you see, the sigma n will become maximum when the value of tan 2 pi becomes equal to this. Now what does this imply? What does this imply? So this tan 2 pi, if you now come to here, so I have done the same derivation over here. So you see tan 2 pi is equal to minus 2 tau xy sigma x minus sigma y. Okay? Now if you remember from the trigonometry, okay, so what is actually tan phi? Tan phi is nothing but sin phi by cos phi. Correct? Tan phi is nothing but sin phi by cos phi. Now you see the value of sin phi and cos phi. If you remember sin phi and cos phi or sin theta cos theta, so you see sin theta remains sin theta when 180 degree is added to it. Correct? So sin theta is equal to sin 180 plus theta. Remember this? Value of sin becomes same. Value of sin theta becomes same if theta again goes to theta plus 180. And value of cos theta becomes minus of cos with the minus sign. The value becomes 180 plus theta. Okay? 180 plus theta. So considering this, what you are getting? So if I do sin theta by cos theta, if I do sin theta by cos theta, that means what I can write? I can write sin 180 plus theta by cos 180 plus theta, and with a minus sign. Tan theta is equal to sin theta by cos theta, correct? Which is equal to nothing but sin 180 plus theta by cos 180 by theta with a minus sign. What does it mean? It means that the value of tan theta, okay, will basically differ by 180. Means value of tan theta differs by 180 degree. Or so I should not say tan theta. The value of theta differs by the value of 180. So if I am having an expression of tan theta is equal to minus something, which I am getting over here. So if I consider this 2 pi as theta, then what I am getting? Tan theta is equal to minus 2xy sigma x minus sigma. So what does this signify? This signifies that theta is either tan theta or tan 180 plus theta. Okay? So basically theta, the value of theta is giving rise to the value of two conditions. Okay? And that differentiation of the value, so this condition gives two values of 2 phi differing by 180. So if one value is 10 degree, other value will be how much? 190. So this condition gives you the value of theta, or here we can say theta is what? 2 phi. So 2 phi should be differing by 180. So that means with this condition of tan 2 phi equal to minus 2 tau x by sigma x minus sigma y, what are you getting exactly? You will get value of 2 phi, two values of 2 phi, right? So one value of 2 phi, one value of 2 phi will give you what? One value of 2 phi will give you, one value of 2 pi will give you maximum value of sigma n, where the sigma n is occurring, and the other value of 2 pi, which will be separated by 180 degree, will be giving minimum value of sigma n. So there will be two planes where the 2 pi angle will be separated by a value of 180 degree. So if 2 pi is separated, by 180 degree, then what will be the value of phi? So phi will be equal to 180 degree by 2 is equal to 90 degree. Got it? So this is a very, very critical information regarding the plane stress problem. What is the information now you are getting? So this means that the normal space will be occurring at a plane, and the minimum normal space and maximum normal space will be occurring at two different planes, which will be separated by an angle of how much? By an angle of 90 degree. That means the minimum normal space and maximum normal space will be perpendicular to each other. Okay? And the planes on which the normal spaces will be acting, those will be also perpendicular to each other. Have you understood? This is called the orthogonal property of the principal spaces. Orthogonality means they are perpendicular to each other. So the planes on which the normal spaces will be occurring, and the maximum normal space and minimum normal space will be happening at a plane perpendicular to each other. And to this place, the normal space directions, whatever will be occurring. So if there is a normal space in this plane like this, so this normal spaces, two normal spaces will be also perpendicular to each other. Have you understood? Is it clear? So this is a very, very important condition. And this maximum and minimum normal spaces, you will see there is a very, very beautiful thing coming out in the next derivation, whatever we will be doing. Small derivation we will be doing. And then if you see, if the value is differing by 90 degree, okay, if the value of the two planes is differing by 90 degree, then what will be the state of shear stress in those planes? Let's see that. What will be the state of shear stress in those planes? Okay. So which planes we are talking about? The planes where the normal stresses are becoming either maximum or minimum. Right? So what will be the shear stress in that? So how do you find out that? So if you see, so you can see for one of the value of phi, sigma n will be maximum, I have explained, and the other value will be minimum. Right? So now you see, if we think about the plane, now if you think, let's assume that there is a plane exists where the shear stress becomes 0. Okay, you assume, just assume, and then you will be able to establish a relation. Okay, what is the relation? Let's see. So if I assume that shear stress becomes 0 at some plane, then you see a very beautiful condition coming out. So shear stress, what we are assuming? We are assuming shear stress becomes 0. What is the shear stress in the inclined plane? Shear stress in the inclined plane is this tau, right? So if tau is the shear stress, then if tau becomes equal to 0, if I assume tau becomes equal to 0, then what happens? Then you see this term sigma x minus sigma y sin 2 pi plus tau xy cos 2 pi becomes equal to, correct? So from this equation again you find out that tan 2 phi will be equal to minus of twice tau xy by sigma x minus sigma y, isn't it? Have you understood? Is it clear? Tan 2 phi is becoming equal to minus tau xy by sigma x minus sigma y. Now you see the relational thing between when we have found out the maxima minima condition for the normal space. So when we have done d sigma n d phi equal to 0, that means the maxima minima condition for the normal space. What is the condition? What is the final result we have got? We got tan 2 phi. We got tan 2 phi equal to minus 2 tau xy by sigma x minus sigma y. Isn't it? We have got the same relation. So you see the plane where the maximum and minimum normal spaces are occurring, and if we assume that shear stress is also 0, then in that inclined plane, then you see we are getting the same relations. We are getting the same relations, isn't it? What does it imply? It implies that the normal space occurring where the normal space is maximum and minimum at a particular plane, okay? And which plane? The planes which are separated by 90 degrees. In those planes, the shear stress value obviously will become equal to 0. Have you understood? Because you see from the relation, and with a small assumption, we have proven that both the conditions of the maximum minimum of normal space, and if we put a condition of assuming that shear stress becomes 0, in both cases we get an equation tan 2 phi equal to minus 2 tau xy by sigma x minus sigma. So this implies that the normal stresses which are maximum and minimum at the place where it will become maximum and minimum, along those planes, the acting shear stresses value will become equal to how much? 0. It will become equal to 0. So the planes where the maximum and normal where the maximum and minimum normal spaces are occurring, those planes are called principal planes. Okay? In solid mechanics or in any kind of this kind of discussions, we'll call this kind of planes where the normal spaces are becoming maximum or minimum. Such planes will be termed as principal planes, right? And in the principal planes, we'll see the value of the shear stresses will be always equal to 0, and the principal planes will be at an angle of 90 degrees to each other. Okay, so that is what I have tried to explain here. So we can say where the normal spaces are minimum or maximum or minimum, shear stress on such plane will be 0. Okay. On the other hand, the corresponding normal spaces, that is sigma n max or sigma and min are called principal stresses. The planes will be called principal planes and the stresses will be called principal stresses. The planes on which they act are called principal planes. By how much angle they will be getting separated? The principal planes are at angle 90 degree to each other. On the principal planes, the value of shear stress will be equal to 0. So have you understood? This is a very, very important concept. What is principal stress? What is principal plane? How they are separated? What is the value of shear stress at the plane where the principal stresses are occurring? So these are very, very important things and points to understand. Okay. Now let's go to, so till now whatever we have discussed, it is related to normal stress, right? So where the normal stress is becoming maximum, and in that normal stress becoming maximum, we have taken an assumption that shear stress becomes 0, and we have found out that the condition for normal stress becoming maximum with a value of tan to phi, they are becoming same. Okay. Now we will have to find out where the shear stress will become maximum. What will be the condition for shear stress becoming maximum? This is another one point you should understand. Okay. So where will be the shear stress becoming maximum? So now let's see how do you find out shear stress becomes maximum. So what will be the condition for shear stress becoming maximum? Can anyone tell? So what I have to do? What will you have to do? So for shear stress becoming maximum, you need to again differentiate what? You need to again differentiate the value of shear stress tau with respect to what? Tau. So we will differentiate this tau with respect to tau. So d tau d phi should be equal to. So for maximum minimum shear stresses, d tau d phi should be equal to 0. Correct? So if I differentiate, please differentiate. So if I differentiate this part, what will be the differentiation? So this will become half of sigma x minus sigma y into 2 cos 2 phi minus 2 tau xy sine. This should be equal to. Correct? Is it clear? So now simplify and try to put it in terms of tan or cos, something like that. So if you see, if I take this part on the other side, then what will become? This will become so 2 cancels out. If I take this on the other side, then cos 2 pi by sin 2 pi, I will get a term cos 2 pi by sin 2 phi, which is nothing but what? Cot 2 phi, right? Cos 2 pi by sin 2 pi is equal to cot 2 phi. And cot 2 phi will become equal to twice of tau xy by sigma x minus sigma y. Have you understood? So you see d tau d phi, that means d tau d phi equal to 0. That produces a condition like cot 2 phi equal to 2 tau xy sigma x minus sigma y. And if you remember, for the normal stress, what is the condition we have got? So in normal stress, we have got d sigma n by d phi equal to 0. In this condition, we have got a condition where we have got tan 2 phi. We got a minus sign, right? We got a minus sign. Minus 2 tau xy by sigma x minus sigma y. Okay? Have you understood? Correct? So you see tan 2 phi, this one I am getting tan 2 phi, other one I am getting cot 2 phi. So what is cot 2 phi? Cot 2 phi is nothing but 1 by tan 2 phi. Correct? Cot 2 phi is nothing but 1 by tan 2 phi. And if you see this established condition, you see there is a similarity between the condition. Here we are getting tan 2 phi equal to minus some. On the other hand, we are getting cot 2 phi equal to 2xy sigma x minus sigma. So when we are thinking about tan 2 phi, so how have I explained you? So tan theta, value of tan theta becomes equal to tan 180 plus theta, right? And it brings you a minus condition because sin theta equal to sin 180 plus theta and cos theta equal to minus cos 180 plus theta. That's why tan theta equal to becomes, so theta and tan 180 plus theta will produce a different sign values, right? On the other hand, if you now see this cot 2 phi, so let's go to this one. So we have established this. So if we consider the previous equation, we have got tan 2 phi equal to minus 2 tau xy sigma x, and here we have got 2xy sigma x minus sigma y. So what is this condition? Condition for principal stresses, where the shear stress is 0, right? This is the condition for principal stress, where the shear stress is 0. And what is this condition? This is the condition for what? Maximum shear stress, right? So compare these two conditions. Okay? Now if you compare these two conditions and just go by an assumption, go by the trigonometric relation. What is cot theta? What is minus cot theta? What is minus cot theta? Tan pi by 2 plus theta should be equal to minus cot. Tan pi by 2 plus theta should be equal to minus of cot. Correct? So if we take this assumption, to this one, then what we are getting? So you see, this shows what it actually shows. In the other case, what you have seen, 2 pi were separated by 180 degree. Now here, what we will see? We will see the separation angle of 2 pi should be equal to how much? Pi by 2. So that is why this shows the place where the principal stresses are occurring and where the maximum shear stresses are occurring are separated by 2 pi. That is equal to pi by 2. Okay? Why? Because you see, we have established a relation between tan 2 pi equal to minus cot 2 pi. What does it mean? See, this equation and this equation, what does it show you? Tan 2 pi equal to minus cot 2 pi, isn't it? Have you understood? Or you are not getting? Please tell. Very, very important condition, because when you will be moving to more circular construction, these will come into picture. Because you have to explain at that time what will be the value of 2 pi. From 2 pi you have to find out value of pi. Okay? So if you have any confusion, I can clear the doubt now itself. Okay, but I don't think you should be having any doubt. It's a very, very simple trigonometric relation. Trigonometric relation. So you have seen tan 2 pi is this, cot 2 pi is this. This is having a minus sign. Values are same. What does it mean? Tan 2 pi equal to minus cot. Right? And how does tan and cot related? Tan 2 pi equal to minus cot. So how does tan and cot related? You can see tan pi by 2 plus theta is equal to minus cot. Right? So what can I write here? I can write tan pi by 2 plus 2 pi is equal to minus of cot. Can I write that? So there will be two planes again coming, which will be separated by pi by 2. And with what that will be separated? It will be separated with the principal planes, isn't it? So with the principal plane, because we are considering this tan 2 pi. So we are putting tan 2 pi is equal to tan pi by 2 plus 2 pi, right? So there will be two planes coming where 2 pi will be separated by an angle pi by 2, and where the maximum shear stress will be occurring, and they will be separated by an angle 2 pi equal to pi by 2 and making an angle with the principal stresses. So what will be the value of phi? So if 2 pi equal to pi by 2, phi will be equal to how much? Pi by 2. What does it signify? What does it signify? So the where the maximum shear stresses will be occurring, they will be making an angle 45 degree to the plane of maximum normal stress or minimum normal stress. So the maximum shear stress or minimum shear stresses will be occurring at planes which will be making an angle of 45 degree to the plane of maximum principal stress or minimum principal stress. Is it clear? So there is a separation angle of 45. Clear? So now you see, so what does it give you actually? So it gives you, if you can find out the place where the maximum shear stress is occurring, where the maximum normal stress is occurring, if you add a 45 degree to that, then you will get another one plane where the maximum shear stress will. Have you understood? Is it clear? So if you see, if you have pi is equal to 30 degree over here, and if your sigma is maximum over here, how much will be the value of tau? Suppose pi is equal to 30 degree, I am telling you. Pi is equal to 30 degree. Okay? And at pi is equal to 30 degree, your normal stress is maximum. I give you a condition. Okay, maximum. So if the normal stress is maximum, then this sigma and this sigma is max. Correct? So what will be the value of tau in this plane? The value of tau will be 0 because normal stress is maximum. Okay? So where the value of shear stress will become maximum? The value of shear stress will become maximum at 30 plus 45 degree at 75. So when this plane will be rotated in anti-clockwise direction and it is going to 75 degree, it will become maximum. Have you understood? Is it clear? So with this understanding, we can see very important thing. Many competitive examinations, many interviews, you will be asked this question. What is principal? What are principal stresses? Okay? What will be the shear stress at a principal plane? Does principal stress become 0 at the plane where the shear stress becomes maximum? These are the questions generally being asked. Okay? Now we should be clear on all these points after this discussion. And finally, what we are concluding is, therefore we can see that the principal planes are orthogonal to each other. I think you should not have any doubt now. Tan 2 phi equal to minus 2 tau xy divided by sigma x minus sigma y. From that relationship, we have established that phi will be separated by an angle how much? 90 degree. So basically, the principal planes are orthogonal to each other. What does orthogonal mean? That means they are at 90 degree to each other. Okay? The planes where the shear stresses are maximum, minimum. The planes where the shear stresses are maximum or minimum are also orthogonal to each other. What will happen to the shear stress? Shear stress, what we have established the relation? We have established the relation cot 2 phi equal to 2 tau xy by sigma x minus sigma y. What does it mean? It means cot 2 phi means sin 2 phi by cos 2 phi by sin 2 phi. That also means that the planes where the maximum shear stresses will occur, they will be occurring at an angle 90 degree to each other. Correct? And the shear stresses where the maximum shear stress will occur, those planes will be at an angle of 45 degree to the principal stress plane or principal plane. I should not say principal stress plane, it should be principal plane. Because principal plane is the plane where the principal stress is occurring. Okay? So the planes for maximum, minimum normal stresses makes an angle of 45 degree or pi by 4 with the planes of maximum shear stress. This is another one very important one. Okay? And the last one, you see, on the principal planes, the normal spaces are either maximum or minimum. This is clear? So what will happen? On the principal planes, normal spaces are either maximum or minimum. And what will be the value of shear stress? The value of shear stress will be equal to 0. However, you see, on the plane where shear stress is maximum, the plane where shear stress becomes maximum, at that plane need not be principal space will become equal to 0. The planes where normal space becomes maximum, shear stress becomes 0. But where the planes where shear stress become maximum, it need not be that principal spaces will become equal to 0. Is it clear? Have you understood? Okay, very, very important thing you should remember. The two equations, whatever I have explained, and the fundamentals behind the principal space and principal plane, whatever I have explained, that you should very, very carefully observe and study and remember. Okay? Those two equations are very, very important equations. Okay? Now you see, I've gone on by thing. So if you remember, we have seen that initially we have taken 2-3 cases, right? In the primary case we have taken a normal space is active, right? So if only normal space is active, only one directional normal space is active in an element or in a body, what happens? So if only one dimensional space is active and that is normal space, so will there be any existence of shear stress? So you see, the common generic equations are these two. So what do you understand by only one directional normal space? That means either sigma x will be equal to 0 or either sigma x will happen or sigma y will happen. Right? So if I take sigma y equal to 0 as well as tau xy equal to 0. Correct? So if I convert those two equations now, so what will be the value of sigma n? So you see, sigma n becomes half of sigma x because sigma y is 0. Here it will become 0. So half of sigma x plus half of sigma x. So you get half of sigma x plus half of sigma x. Sigma y is 0. Cos 2 phi. So cos 2 phi equal to, and tau xy is 0. So tau xy is 0 means 0 into sin 2 phi. This will become also equal to 0. So you will get equation sigma n equal to half of sigma x plus half of sigma x plus cos 2. So if you take common half of sigma x, you get half of sigma x into 1 plus cos 2. That will 1 plus cos 2 phi. If you remember, I have explained to you what is 1 plus cos 2. 1 plus cos 2 phi is nothing but 2 cos square phi, right? So half of sigma x into 2 cos square phi. This will give you rise to the equation that sigma n will be equal to sigma x cos square phi. Okay. On the similar way, if you make sigma y equal to 0 and tau xy equal to 0, so what you get? Sigma y equal to 0. So you will get half of sigma x sin 2 phi, half of sigma x sin 2 phi, and tau xy becomes equal to 0. So there will be a tau. So you see, an element or a body when subjected to only normal space in x direction, if I take an inclined plane which is occurring at an angle phi with the x plane, then the value of normal space will become sigma x cos square phi, and the value of shear space you can see from there. So then this is the angle phi. So there will be a normal space existing and there will be a shear space existing. Have you understood? So need not be that you require a shear stress to have a shear stress in the inclined plane. Correct? See, there is no shear stress applied in this body. However, still at an inclined plane, the existence of shear will come into picture. Have you understood? Clear? So this is the case number 1. I think already it is time, right? So we'll stop here. Case number 2 we'll understand in the next class, along with the concept of how to construct more circles to describe the plane space condition through a circle. Okay, that is another one very important concept you should understand. And hopefully by another 2 classes you should be able to complete this plane space chapter, plane space equation chapter. Okay, so thank you.